I just want to see. All right, that looks pretty decent back there. All right, let's get started. So like I said, here is like the beginning. This is like the part of the whole geometry thing that's kind of like out of the box. And we have to kind of think. So, let me get my notes. Let me get prepared because, you know, I don't prepare. All right. First off, I told the peeps over here that I'll show you. We went to the zoo for my son's first birthday. Super cool. But the lion actually was roaring. How has that ever happened? Like, I don't know about you. I don't go to the zoo very often, but
Felt like Lion King.
I did. It is expensive. It wasn't too bad. I mean, for 2 kids. I mean, that he's under 2, so. Okay. I don't want it to be too loud. Okay. Didn't sound like he has a hairball. But he did this like 4 times. That's great. But hold on. Do you hear the beginning roar? It's like. I mean, you can feel it like booming in your cerebellum. Like it was like.
Your cerebellum.
I just felt like I had to say that. I just had to get it out of my system. All right. So I thought that was really cool, and Clyde was kind of just eating his snacks and sharing it with the animal, or so he thought he was sharing them. I mean, he can really only throw it to his feet, and so he was like, all right, so we're going to be proving angles congruent. So this is where the proof starts, and I have told many of you guys I try to keep this on the DL, like really try to keep it low-key.
Yeah, low-key.
You have to, because it gets really complicated and it gets really hard and confusing. So when you're proving angles congruent, we're ultimately going to be proving theorems. So we're going to be given properties that we can use to say, hey, yo, I know that this holds true. Using certain properties, using certain postulates that hold it to be true. And then ultimately we're going to be proving a theorem. There has to be some way that we can prove 2 angles congruent. There has to be a way that we can know that this angle is congruent to this angle due to these blah, 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 blah. A proof is literally steps. It's like, hey, oh, this is why this matches, this is why this matches, this is why this matches. And I try to keep it very, like right here. Top notch, we're all going to give up. Here, maybe a little of you guys will try. So a theorem is a conjecture or a statement that you can prove true. So I don't know about you guys, probably none of you guys really know this, but in science you can't ever prove anything. So what is it? Who is the 3 laws of physics? Who is it? Is that Einstein? Oh, there you go, Newton. There we go. So Newton, he did not create the fig Newton. Sheldon would be very disappointed if you thought so. So like Newton's 3 laws. They were just able to, like, they're just saying, okay, I've tested this multiple times. They can just say it's pretty much going to happen. However, you can't ever prove science. Never, ever can you ever prove science. In math, however, you can prove something to be true or false. So that's really cool because you're sitting here, you're like, oh, so if I went back and I was like, I'm going to outsmart Newton, is there a way that I could show that this actually isn't going to be true? But this is the thing, is you can test it over and over and over again, which is what Newton did. And that's why he was able to come up with this idea that this will be held, like it will hold true to the end. However, you can't ever say it's like finite. You can't say, hell yeah, this is always true, no matter what. Because there's going to be that one time that something's going to change, and now he is disproven. So it's really kind of weird, because you're like, all these things, if you think about when, Darwin, who's sitting here and believing in, he believes in natural selection. So he's saying that the same bird, the cardinal that we see here in Arizona, is not the same cardinal that you see in South Carolina. Somehow they made some kind of adaptations based on their living experience. Which Darwin is like totally, okay, Darwin, that's like, that makes sense because it's like super duper hot here and super duper cold there. However, there could be that one time where they can see the same thing and where they can say natural selection isn't going to hold true. Okay, we're not getting into science.
Well, like anything with opposite or equal reaction.
I don't even know his 3 laws, but the one is you're saying with the same force, you're gonna have the natural action. There's gonna be the same reaction.
Yeah.
So if he's gonna hit him, this is gonna come back and hit him.
It's for every action there's an opposite or equal reaction. Something
Okay.
like that.
So vertical angles. That's our start. So vertical angles, it says if, right off the bat, vertical angles are congruent. Vertical angles, the best way I can explain them is they look like kissy faces. That they're right across from each other. They're not necking, but they're giving Eskimo kisses, right? So here I am, I'm Eskimo kissing my pen. They are literally staring at each other in the face. So if I'm going to draw this, the best way that we can see vertical angles are an X. If I say this is my bird, my bird.
Butterfly.
No, it's a bird.
That don't look like a bird.
That's a beak. There's my birds. So if I have my bird, their 2 noses are touching. The angles that create the nose have to be the same angle. So their 2 beaks have to be congruent. So if angle A and angle B are vertical angles, so now I'm stating to you that they are, this is true, then the measure of angle A is 15. Therefore, measure of angle B has to be 15. Congruent, the word synonym for congruent means same. So if I'm telling you vertical angles are congruent, I'm telling you that the vertical angles measures are the same. What? What? What are you winning?
What about a bullet?
Could have, would have, should have, but you didn't do that.
Why do you?
Okay, so what we can use knowing about vertical angles. So knowing that they are congruent, if I give you a value for a vertical angle, you are able to actually solve for an unknown length, or unknown angle, sorry, not length. All right, Jorge, and is it Melissa, is that you next? Yes, go ahead and go. So we can use, knowing that vertical angles are congruent, we can use and set up a equation. Circle the word that best describes the label pairs in the diagram. Are they corresponding? We haven't really talked about corresponding. Hey guys, I'm talking. No. Corresponding angles mean they're in the same position of a figure. In this case, if we literally look at these 2 angles, are they in the same position? Well, if I'm looking at this angle right here, he looks like he's a bottom angle, and if I look at this angle, he looks like he's a top angle. So they're obviously not corresponding. They're not in the same damn position. Perpendicular, do they look like they create a 90-degree angle, those 2 angles together? No. So they're not corresponding, they're not perpendicular, they're vertical. So they're kissy faces. And we know, based on the definition of vertical angles, we know that vertical angles are always congruent. They're the same. So, therefore, since we know that they're same, we can set them equal. Because same, if I gave you $50, that's the same as having $50. If I gave you $100, that's the same as having $100. So if I give you 3x, that's the same as having 2x plus 40. They're the same thing. We can solve for x. So using the labels in the diagram, we can write an equation. We have 3x is equal to 2x plus 40. It's now a 2-step equation we can solve. I'll show my work over here. So 3x equals 2x plus 40. Your end goal is you ultimately want your 2 separate topics on the other side of the equal sign. So you want your x's on one side, you want your whole numbers on one side. So I already have an x by itself, so I want to bring any other x to him. So since 3x is already by himself, I'm going to bring 2x over. To undo a positive 2x, we are going to subtract 2x. 2x cancels, I'm left with 40. What's 3x minus 2x? 1x. Which again, 1 times anything is the number itself. So doing this is going to be kind of stupid, but we can do it anyway. How do I solve for x? I don't have that 1 up front. Divided by 1. And what's 40 divided by 1? 40. So x equals 40. Our degree doesn't equal 40, x equals 40. Now, if we wanted to know our degree measure, we can take our x and plug it in. times 40. What is 3 times 40? 120. And then if we have 2x, so 2 times 40 plus 40. What's 2 times 40? 80. What's 80 plus 40?
And I can change for you. I don't have any.
Oh, so what are they both equal?
420.
Is that true? Is that what we are supposed to get?
Yep.
Yeah, they are congruent. Your vertical angles must be the same. 120 is equal to 120. This is the way that you can check if you got it right. Why sit here and wonder if you got it right when you can easily plug in your value for x and tell yourself if you got it right or wrong? All right, can I erase that?
Sure.
Shake. Am I good with you? Am I good? Okay. You're the one who said no, so I just want to make sure you're good. Okay. So, find the value of x. So again, we have a set of vertical angles. They are across from each other. They are kissy faces. Here's my bird. So if they are pecking at each other, then you know that you have vertical angles. Isaiah, both of you. No. So we know that their angles, vertical angles are what? They're congruent, which means what?
The vertical.
Okay. Yes. What does congruent mean?
Same.
The same. So we can set them equal. We know that 2x plus 21 is the same as 4x. 2x plus 21 equals 4x. Vertical angles are congruent. That means that they're the same. That means that they are equal. 50 is equal to 50. 200 is equal to 200. You can set your two angle values equal to each other and solve for x. I want you guys to do that on your own. So go ahead. I've set up the equation. Solve for x. And then I want you to go back in and verify, does that really hold true to make your two angles congruent?
Mrs. Cope, I go.
Yes. I helped you. I told you that vertical angles are the same. You know that they're vertical, they're kissy faces. If their two nuzzles move, they are the same. So if they're equal, if they are congruent, if they are the same, you can set up an equation and solve for x. Here's your equation. Solve for x.
You got it.
Do I let? I don't have any other. Do you want to go up to show that the degree is equal to that? Go back and check your work. Plug your x back in and see if those angles are truly equal. Plug it in. Instead of 4 times x, you can say 4 times 10 and a half. Yep. Just plug it in. Just like what we did in the warm-up. 1, 2, and 3. Maybe not. Let's plug it back in. All right. Abby come up and she's going to solve it on the board. I suggest when you come around, you make sure that you look, because there's a couple of you guys, you kind of solved a little differently. So I want you to make sure that you solve for x correctly. And then after that, Antonio's going to come in and he's going to show you how the angles come out to be equal. Yeah, they are. Well, you can verticals anyway. I always like it this way because you can see the faces. Oh, because they should be like this way. Yeah. Those should be horizontal, right? All right, perfect. So what Abby did is she subtracted 2x from both sides because we have an x by itself. Remember, that's the whole point when you're solving an equation. You want all x's on one side, you want all whole numbers on the other. So we already had a side with x by itself, so she subtracted 2x from both sides. She got 21 equals 2x. She divided both sides by 2 because she wanted to get x by itself. And when she divided 21 by 2, she ended up with x equals 10.5. Antonio, go up there and tell me how you evaluated to show that the angles truly were congruent. That's why I had to look down there. It looks super duper big. Huh? Oh my gosh. Look at you. Perfect. So what he did is he took, for our left angle, he took 2 times 10.5. He got 21. 21 plus 21 is 42. And then when he multiplied 4 times 10.5, he ended up with 42 degrees. Well, it says vertical angles must be congruent. They must be the same. So therefore, 42 is equal to 42. That's true. So like I said, it behooves you, which means it's totally worth it. So it behooves you to plug in your value for x to see if it's truly true. Because I'm going to tell you, you give me a value for x and it's wrong, I'm like, what the hell were you doing? You could have easily known if you were going to get this question right or wrong by plugging it in. All right. Oh, my face. It's going to snapshot it. Sorry, guys.
What?
I accidentally captured it. So it's saving the ink notes. I took a picture of it. It's kind of like when you took your phone and you can screenshot it. I like screenshot it.
That sucks. Regular way to go.
Yeah, Smart Notebook takes like 900 hours to load up. It's like,
Alright, thanks. I'm gonna go get my phone now.
ain't no time. Ain't nobody got time for that.
Losing trust in your screenshot.
What?
You're losing trust in your screenshot.
You're losing trust.
It's a joke.
But I don't. What, did I betray your trust by taking a screenshot?
Yeah, like if
No,
you
I
send something like
just
a
taking up the
Snapchat.
time, miss.
I'm gonna totally send it to somebody. Just, take our time. We're gonna. Okay. See, look it. Just take a picture of the whole thing. Okay. All right. So.
Why don't we need supposed to get called smart boards?
Smart boards. Why? Because they're obviously dumb people. I don't know. All right. So.
Can we just go back to the old time? Whiteboard?
Oh, I love the whiteboard. All right, so I'm going to talk about each one of these properties. Each one of these properties, instead of having you write it out, because I really could have been a bitch and had you do that, but I wasn't. I thought, hey, we'll talk about each one of those, and I expect that you guys are listening. So that means that the cell phones are off, you're facing forward, and I'm going to literally do the best that I can to explain these things. These are the properties in which we use to use proofs. So So when we are proving two things congruent or something like that, I can bet your bottom dollar we're going to be using something along the lines of these two different properties. Okay, so your properties of equality. Equality means equal. The two ways that we can, or the two ways, the 900 ways to show that they are equal is this. We have the addition property of equality, which this should make sense. If I had both $5, so I had $5 in my right hand, $5 in my left hand, and I put $1 in both hands. Put $1 here, put $1 here. Because I gave both hands $1, they should still be equal. They started off equal. I gave them $1. Do they stay equal? So 5 plus $1 is 6. 5 plus $1 is 6. So they are still equal. So the property of the addition property is saying that if you add the same value to both the left and the right side of your equation, it should be the same. You don't have to worry about anything. You really didn't change anything. The subtraction property is the same idea, but instead of adding something to both sides of the equal sign, you are now taking away. So again, if I had $5 and I took $1 away from here and $1 away from here, would they still be the same? Yeah, because 5 take away $1 is 4, 5 take away $1 is 4. So as long as they have the same values already, and you subtract the same values, they will still be the same. Multiplication property. It's saying, I have the same value, and I said you had $5, I'm going to increase your pay by 2. So now you should have $10 in your right hand, and I increased your value, I multiplied your pay by 2, you should have $10. So as long as you have the same values, and you multiply by the same value, they're still going to stay equal. And although they use A equals B, A and B, they're telling you right off the bat that A and B are the same value. They're just using two different letters, okay? So they're saying A equals B. A and B are the same value, just different letters. And A and B are some arbitrary. Arbitrary means random, okay? So it doesn't matter what A and B are. These properties hold true because A equals B. The division property, as long as your value isn't, you can't divide by 0, that's a no, that's not good, that's undefined, that's not real. As long as C isn't 0, whatever you have, you can divide it by the same value. You can divide your left side and your right side by the same thing, and they'll still be equal. Okay, the reflexive property. They're saying that A equals A. Is that true? Is 2 equal to 2? 4 equal to 4? 5 equal to 5? That's the reflexive property. If you think about it, it has a reflection. Oh, if I'm staring at myself in the mirror, are we not the same person?
No.
That's weird. That's funny because when I look at myself, I now become a man that's like 6'5", and I'm like, that's so weird. I'm gonna put my makeup on as if it was normal. Okay.
Real?
Yeah, do. So the reflexive property is saying that you have a reflection. You see the same thing on both sides. The symmetric property is saying A equals B is the same as B equals A. It doesn't matter the order they are. It's kind of like the commutative property. If I drive 5 miles this way, it's the same as driving 5 miles this way. It doesn't matter if I go forward or backward, it's still 5 miles. The symmetric property is saying the same thing. A is equal to B. A is equal to B is the same as if I did B is equal to A. Because they're equal to each other. 5 is equal to 5 is the same as 5 is equal to 5. It doesn't matter. Since they are equal, we can look at them in opposite directions. The transitive property. Okay, so what the transitive property means, this is like one of the big guys. This is like the top notch right here. So the transitive property, this is certainly something that we are going to be using very much when we are getting into the proofs. Transitive property means, the whole point of the transitive property is like we're getting rid of the middle guy. We don't care about him. Whatever middle guy is repeated for both any statement, we can get rid of him. So that's like saying if I'm driving, I pick up Hiram. Hiram's driving to pick up Monique, and now me, Hiram, and Monique are together. Well, technically, I didn't necessarily need to pick up Hiram to get to Monique. I knew where I was going. So I can ultimately throw Hiram out of the door and say, hey, oh, I know how to get to Monique, so you're not the only one who does. So the transitive property can get rid of the middle guy. And the way they explain it is they say if A is equal to B, let's give a value for A. So if A is 2, and it's saying A is equal to B, what does B have to be? 2. So B has to be 2. Then it goes to say that B is equal to C. So what does C have to be?
2.
I technically didn't need to get B involved. I didn't have to get B involved, so I can just say that A is equal to C. Or don't you agree? Can I not just say A is equal to C and you guys know that that has to both be 2?
Yeah.
I technically didn't need to get B involved. And we call that the transitive property, which is going to help us because we're going to say, hey, me and Hiram are the same degree. Hiram and Stephanie are the same degree. Technically, we didn't need Hiram and me and you are the same degree. So we can get rid of the middle guy. The middle guy is always going to be repeated. Here's your middle guy. A is equal to B and B is equal to C. Fuck, they said B twice. I can get rid of him. So anytime they are repeating something, you can get rid of him knowing that the transitive property is true. Transitive, you know, like a transport you. You don't need the middle guy to get yourself to... Okay. Substitution property. It's saying if A is equal to B, then B can be replaced with A. So if A is equal to B, and I told you A was 4, what does B have to be?
4.
And it's saying that if I had the expression 2A, I can ultimately replace A with B. So I could do 2A, or I could do 2B, and they would both be the same. To be or not to be? That is the question. Okay.
You just like Shakespeare, right?
Sure did. All right, so here is the property using more like real life. So this is showing that things are congruent. So it's using the reflexive property, symmetric property, and the transitive property. So this is like the real life stuff. The before was just talking about a value. This is talking about lengths. This is talking about degrees that we can hold true to help us prove. That's why it's called properties of congruence, which that comes from the word congruent, which we know congruent means what? Same. So we have the reflexive property. That's saying that line segment. The reason I know it's a segment is because it doesn't have arrows going. A line segment stops. It's literally saying AB. The length of AB is congruent. Here is the symbol for congruency. It's a little squiggly. The reason why we have that squiggly is because that's a squiggle for similar. So then after we get into congruence, when you get into GOB, we're now going to talk about similar figures. So congruent figures, we're going to use the symbol for similar. However, we need to say that they're the same. That's where the equal sign comes in. That's why there's an equal sign in the label of congruence. So we can say that the length of AB is the same as AB. Remember, reflexive is like a reflection. So AB is congruent to AB. They literally didn't change anything. It's a reflection of itself. And it's also saying that angle A is congruent to angle A. Or angle B is congruent to angle B. Angle C is congruent to angle C. I mean, we can sit here all day. So it's literally the same thing twice. That's what the reflection, because it looks like a reflection. It's literally the same thing. The symmetric property. It says that this line segment, if AB is congruent to CD. So here's AB, here's CD, they're already congruent. That's the same as if I said, if I put CD first, I said, hey, CD is congruent to AB. It doesn't matter the order. It's like commutative. It doesn't matter if I drive 5 miles forward or 5 miles backwards. If I look at my speedometer, I'm still having 5 miles. However, if you were reversing 5 miles, I'm pretty sure you'd be pulled over.
Not if you do this.
For the angle, so it's saying angle AB is congruent, angle A is congruent to angle B. That is the same that angle B is congruent to angle A. So it doesn't matter the order. All it does is just switch the position. That's literally what symmetric means. The reason why we would use the symmetric property is because we would ultimately use it to help us get to the transitive property. So if you see something repeating, so if you had angle 1 is congruent to angle 2, and then you had angle 3 is congruent to angle 2, hey-oh, you need to make sure when you're using the transitive property, the middle guy stays in the middle. So we would use the symmetric property to say that angle 2 is congruent to angle 3, to therefore use the transitive property to cut out the middleman. So it says if angle A is congruent to angle B, and angle B is congruent to angle C. Do you see where this middleman's coming from? Angle B is repeated twice. I don't like talking, neither does B. So we can cut B out of the picture and ultimately just put in our first and our last. Angle C has to be congruent to angle C. Angle A has to be congruent to angle C. We got rid of the middleman. We didn't need him there. It was like me, hey, can you tell Antonio that he sucks? And then she goes and tells Antonio that you suck, when I could have just easily said, Antonio, you suck.
That's pussy.
No, he doesn't suck. This is just the best example. All right, and it works if we were going to use it a different way. So it says if angle B is congruent to angle A and angle B is congruent to angle C, then angle A is congruent to angle C. This is when we would use the symmetric property because we would want to relabel this. So by symmetric property, you don't have to write this, I'm just telling you. So by the symmetric property, we would rewrite this. We would rewrite that angle A is congruent to angle B and angle B is congruent to angle C. Then we can get rid of our middle guy because we don't want to repeat him. Then angle A is congruent to angle C. Cool? We haven't really even learned anything yet. Okay, let's do this. Yeah, you learned words. All right. When you are doing a proof, you are always going to be given a given statement, something you got to start with. Then it also gives you what the hell you're trying to prove. You're not just me like whipping shit out of your butt. No, you're literally going to be, they're going to ask you, this is what the end result, this is what I want you to show. So anytime you are writing your proof, your first statement is always a statement and a reason. You have to explain how you know these things. And your reasoning is going to come from the reflexive property, vertical angles, symmetric property, reflexive property. Things that we know, definition of perpendicular, the definition of parallel. These are all coming from things that you should know. So, I always go and I always write what I've been given, then I go and say, hey, what am I trying to prove? So, right off the bat, it says we are given that angle A, you can tell I'm stuck on the definition. We are given that the measure of angle 1 is congruent to angle 2. So I'm going to go show that to myself. And I show that they are congruent by using the same symbol. So you see how I used one hump? I don't know what you want to call that. Hoop, angle degree, I don't know what you want to do. But because I used 1, I have to use a 1 on 2. If I used a different number, so if I did 2 humps, then you're not saying they're equal. You are wanting to show that they are the same, so therefore they have to have the same symbol. We are ultimately trying to prove, our goal is to prove that angle 1, angle 2, angle 3, and angle 4 are all the same degree. So that's what I'm trying to do.
Y'all are exactly the same.
Huh? Well, okay, it's nice, but I can't just be like, they are. It's like me going and saying,
Yeah, they are.
did you really make this money? And the IRS is coming to me and I'm like, yeah, I did, IRS. And they're like, I need proof. And I'm like, I did. And they're like, I need proof, you're an idiot. And I'm like, but I did. And they're going to be like, dude, I need your pay stubs. I need your W-2s. And if you didn't have medical insurance, I need to show that you didn't have medical insurance so I can bill you more. And then it's like all this stuff. This is things, it's life. You gotta tell yourself, you gotta give yourself some backup. So, we're gonna write the reason. So, the measure, or it says angle 1 is congruent to angle 2. Your first statement, your reasoning always for your first statement is gonna be easy. It's always gonna be a given. So it's a given. We know that the measure of angle 1 and the measure of angle 2 are the same because it was given to us right here. Given. I didn't just whip that shit out. It was right there. We know it says the angle 1 is congruent to angle 3. So now how are we saying that angle 1 and angle 3 are the same? What is something I showed you guys today?
The line?
No.
The beak?
What about the beak? What does the beak stand for?
They kiss.
What are they? What's the real thing? Because if you write kissy faces, it ain't going to be real.
They're the same.
Yes, what is the actual name for it?
Vertical?
Vertical angles. So we know that angle 1 and angle 3 are vertical angles. be more specific, are congruent. So we know that vertical angles are congruent. We know that. I gave you, that was like the first thing about top. I'll kill you. No, you're not, you were talking. Measure of angle 2 and the measure of angle 4. So here's 2. How do we know that the measure of angle 2 and angle 4 are the same?
Vertical angle.
Again, because vertical angles are congruent. Now, the last thing it says, angle 1 is congruent to angle 2, angle 2 is congruent to angle 3, and angle 3 is congruent to angle 4. How do we know that they're all congruent? This is me being too mathy, but I like writing thus. Thus is like your ending statement. Here I am. I'm going to tell you how I know that these are all the same. Which one of the congruency properties that I explained to you guys in the top allows us to cut out all this bullshit? All these people that we know are all equal, but we could literally talk about the first and the last. So thus, by the transitive property, transitive, like a transport. So thus, by the transitive property, we know that all of them have to be the same. Angle 1 has to be equal to angle 4. We can cut out the bullshit of 2 and 3. All right. So using vertical angle theorem to prove the following. Okay. So we are going to use this. We're going to use vertical angles to prove the following. Angle 1 is congruent to angle 4. They use the same symbol. That's always going to be your first statement. Angle 1 is congruent to angle 4. And the reason for that, it was given to us, was provided to us. And then we're trying to prove that angle 2 and angle 3 are congruent.
Yeah.
Well, we're going to get there. Well, what do you mean, are you writing it?
How do you write it?
Literally like that. Your statement is what you're trying to show. Your reasoning.
I didn't ask a question. No, that's somebody else. I'm not going to give you a name.
No, but that's fine. Your statement is your angles. That's all the bullshit of your angles equal to this, congruency, blah, blah, blah. Your reasoning is that's where we're going to use properties. It's not going to be because I said so, because you're a dumb bitch. I don't know. It's not going to be any of those things. Your reasoning is because you're going to actually use the mathematical terminology.
Remember this?
Okay, so angle 1 is congruent to angle 4. And here we go. We talked about this already. How could you guys tell me? I'm going to use the idea. It tells me I'm going to be using vertical angle theorem. So I'm going to use vertical angles. Angle 1 and angle 3. How can you tell me that those are congruent? By definition of vertical angles. The notes are up here in front of Joel. Anthony, the notes are up here in front of Joel. Okay? Then we have, how can you tell me that angle 2 is congruent to angle, oh, hold on, let me rewrite that, sorry. Angle 4 is congruent to angle 2. How do we know that angle 2 and angle 4 are congruent?
By definition.
By definition of vertical angles. Stephanie, are you still using that one?
Is it 2?
Yeah.
Oh, that's fine. I just wanted to know so I could grab another one. When you're done with it, go ahead and just bring it up. I'll leave it up here. All right, so by definition of vertical angles, how can you guys tell me that angle 1, hold on, I gotta see where I'm trying to get at. I want to get that angle 2. Okay, here we go.
Angle 2 is congruent to angle 3.
Well, we can't just say that. We have to use, let me tell you, we're going to be using transitive property. So we need to find a middleman. We need to get rid of a middleman here. Okay, look at this. We have angle 1 is congruent to angle 4. And we also have that angle 1 is congruent to angle 3. So we can get out, we can kind of cut out the bullshit that we know. So angle 1, I'm going to rewrite this. I'm going to do a different color because I just used black. I'm going to use blue again. So I'm going to rewrite this using the symmetric property. Angle 1, oh sorry, I'm going to rewrite this, sorry. Angle 4 is congruent to angle 1 by the symmetric property of congruence. That's my congruency symbol. That looks nothing like it. So let me redraw that. So all I did was just flip this. I flipped these two. I used the symmetric. I said angle 4 was congruent to angle 1. Now I can kind of do this in one step. I'm cutting out the middleman here, angle 1 and angle 1. So do I have to necessarily say that angle 1 is congruent to angle 1?
Yeah.
No. What is angle 1 truly equal to?
Everything.
Cut out the middleman. Look at it. It's a z. I'm cutting out my z. What do we really care about? Angle 4 is truly congruent to who?
3.
Angle 4 is congruent to angle 3 by the transitive property of congruence. We're not done here. Are we at our end result? Did we prove that angle 2 is congruent to angle 3?
Yes.
We did?
No.
Does number 5 say angle 2 is congruent to angle 3?
No.
No, so we have one more step. Who missed me? Okay. Now, we need to somehow replace 4. Angle 4, because we don't want it to say angle 4 is congruent to angle 3. We want it to say angle 2 is congruent to angle 3. Is there anywhere, we're here. I'm going to star this shit. We're at number 5. Is there any other statement, 1 through 4, that somehow we can use a transitive property, cutting out the middleman of 4, that tells us 4 is truly equal to 2?
Yeah.
Which one? What statement?
By the...
Which, okay, yes, vertical, but what statement? 1, 2, 3, 4. Which one ultimately says, which one allows us to get rid of the measure of angle 4? 3. Okay. Abby, can I see your paper for a second? And we're wanting to prove, here's our end result, this is what we want. Angle 2 is congruent to angle 3. Well, we already have angle 3 in the right position, right? Do you guys all agree with that? Do we have angle 3 where it needs to be?
Yes.
Yes, because here is congruent to angle 3. Now, we need to somehow use the idea that we can use, that's what I'm trying to tell you, the transitive property is the biggest deal. That allows us to get rid of the middleman. So our middleman in this case is 4, because that's not what we want. We want 2. So we have to somehow find the middleman which allows us to get rid of 4. Shane, you can sleep on your time. That means at night. So which one of these statements, here's 1, 2, 3, and 4, which one of these statements allows us to get rid of 4, but will somehow replace it with 2? 3. So let me get rid of all the rest. Here's 4. Got rid of him. Got rid of 2. Got rid of 1. Do you guys agree plan here.
Yeah.
Yes, we have 4 written twice. We don't need that bullshit no more. So we can allow, here's our Z again. We can get rid of our 4s. If angle 4 is congruent to angle 3 and angle 4 is congruent to angle 2, we can therefore say
Angle 2 is congruent to angle 3.
angle 2 is congruent to angle 3. What property allows us to cut out the middle guy?
The symmetric property.
No, not the symmetric. Symmetric is just flipping the order.
That's
Transitive property of congruence. So you're going to have to bullet down number 6 under statement, and you're going to have to bullet down number 6 under reason. There you go. We had to figure that out. We had to get rid of some guy. Okay. So you guys should have labeled your own 6. I feel like you guys are 100% capable of that. If you were in kindergarten, I'd be questioning it, but you're in high school. All right. The next thing that we can use is we should know that congruent supplement theorem. What does the word supplementary mean? Does anyone know?
Equals to 180.
Equals to 180.
so half a circle.
Okay. All right. 10-gram challenge.
Why are we doing this?
No, just get one package. Hand them all out.
Hey, alright.
Remember, I take the first tray, the first 3,
Later.
and I'm gonna have a song playing, and during that song, make sure, guys, make sure that you have 7 pieces. Tell me if you don't. All right. All right, you're gonna have a song. You guys can't be mad at my song.
Better be fired.
Doesn't matter. It's my song. And I like it, and if I hear anything more, I'll cut you out of my life, so.
I didn't know we wanted you tonight.
Oh, good. All right, you have the amount of the song. I'll take the first 3 people. Remember, you can choose from a dum-dum or a pencil. And, anything else? Okay. Ready, set, go. Well, yeah.
That's the one we already did, isn't it? Or no? No.
I said you take a break.
Easy. Oh, I know it.
Yeah, you have to make that cake.
Ooh, what's this?
Oh, here's one.
No, you guys can't cover the exam.
What?
Is this going to the exam? That's okay.
Sing once again for me.
No,
A
man.
strange duet. Like how alone was wandering. Not you.
It's a house, kind of. Well, don't swear to him, but you can swear to yourself.